We know the Gauss's law is the easiest way to find electric field. So these are problem electric field due to charged cylinder. So there may be three cases. One is if we want to measure electric field outside the cylinder, inside the cylinder, and on the surface of the cylinder. This is a solid cylinder of radius r and total charge q, and total charge q and volume charge density rho, that is total volume rho equals to q by total volume. Let for case 1 we want to measure electric field in outside the cylinder. Let this is the point outside the cylinder and this is the r, smaller, so condition is smaller greater than capital R. So for this case we have to take a imaginary Gaussian surface taking radius as a small r and length same. So this is also cylinder. For this case okay, so for this case Gauss's law is that E dot ds, indication E dot ds equals to q by epsilon naught. So total enclosed charge equals to q, and E and ds has the same direction, so E dot ds equals to E, and E is a constant for a particular r. So for all over the cylinder r is constant, so E is constant. We can take E as a outside in outside, and ds gives q by epsilon naught, and ds for a cylinder, Gaussian cylinder, E is equals to 2 pi r l, where l is the length of the cylinder, equals to q by epsilon naught. This implies E q by 2 pi r l epsilon naught, and in vector form just take r cap. For case 2, if r less than r, means if we want to measure electric field in between the cylinder, so just draw imaginary Gaussian cylinder in between this, then E dot ds equals to q in by epsilon naught. In this case q in not equals to q, because q in is the total charge in between the Gaussian cylinder, so q in equals to volume of the Gaussian cylinder into rho, that is that is pi r square l into rho. There is pi r square l into rho means total charge qi, total volume pi r square pi capital R square L, that is q r square by capital R square. Therefore E into ds, integration of ds gives 2 pi r l equals to q r square by capital R square. This means E equals to q r square by 2 pi r l r square. There should be epsilon naught equals to q r by 2 pi l epsilon naught q by l also convert to lambda, where lambda equals to charge per unit length. So q by l can become lambda, so lambda r by 2 pi, there will be capital R r epsilon naught, sorry r square epsilon naught, r square epsilon naught. So these three, and there will be another case 3 if r equals to capital R. So just put replace small r in the previous case or first case, E equals to Q by 2 pi r capital R L epsilon naught r cap. So these are three cases, and if we plot a graph with respect to r and electric field, then we see that for the first case E proportional to 1 by r, and second case E proportional to r. E proportional to r, this is proportional to, so in between the cylinder E proportional to r, that is, let this is r, this is also r, then the proportional straight line, and then this should be 1 by r. So graph is like that, E proportional to 1 by r. So there should be also symmetry in opposite side. Okay.